Okay, boys and girls, we are going to continue our decimal lessons. This is going to be lesson 10 in chapter 13. We are going to be dividing with money. Now, this is not the first time you have done division that involved money. You already did that in our unit on division. But now we're going to think of it from a decimal perspective, okay? Previously, you would do something like regular straight up division, and it was the full dollar amount was given to you as the divisor. But now let's say you're given a different problem. Let's say you're given this word problem. Martin designs greeting cards. They cost 50 cents each if you buy them separately. Or you can buy a box of 25 cards for $12. Which is the better buy? Now, what they're saying when they mean by what is the better buy, they mean which will cost you less, okay? So you're going to have to do some division here to figure out what it's going to cost. The important information in your problem was that each card that Martin makes is 50 cents. If you buy them separately. Okay, but if you buy a box that has 25, let me stick the word of in there. If you buy a box of 25, it's going to cost you $12. Okay, so we can't just look at this and know this off the top of our head. We know what if you buy them separately, what it's going to cost for each individual card. But when you buy a box of 25, we only know how much the whole box costs. We don't know what each card inside that box actually winds up costing us. So we have to do a division problem. So let's set up our division problem. We'll put our total cost underneath because it is our dividend. I'm going to space that out a little bit because I almost wrote 25 instead of writing 12. 12 because that's the total cost. And then I'm taking this whole cost of $12 and I'm dividing by each of the 25 cards that are inside to figure out how much one card would cost. Okay, now you have to remember that when we were studying earlier in this lesson, we already learned that when we saw 25, that it was the same thing as 25.0, that they were the same amount. Or if we had 21 and 1/10, that was the same amount as 21 and 10 hundredths. These two amounts equally. This equals that, and this one equals that. Even though they look like they have more places, they have the same value. I'm going to rewrite that because that looks a little sloppy. 21 and 10 hundred. It doesn't matter how many zeros you add after the last digit. It will, once you put a decimal point in, it will equal the same value. Well, the same thing happens with money. $12 written this way is the same thing as if you wrote $12.00. These two amounts are exactly the same. So what we have to do here is we have to first put in our two zeros, okay, so that we have enough spots to divide into. All right, so now before we do anything else, we're going to put our decimal point in our quotient and we're going to put our dollar sign in our quotient. Otherwise, sometimes we forget and then it's going to be a whole number. It's not going to be a money amount. It's not even going to be a decimal, okay? So in your quotient, you put your dollar sign and decimal point directly above where they are in your dividend. Okay, we've done that. Now we're also going to go back to what we remember from our little saying a sentence that helps us remember the order of the steps in long division. Does McDonald's sell chicken burgers? Remember that? Okay. Told you can't ever forget anything in math class. All right, so let's first figure out where we're going to begin our answer. Well, we know that it at least has to be a 2-digit number because the divisor's 2 digits. So 25 won't go into 1 and 25 won't go into 2. So it has to be one of the, at least 2, but possibly 3. And in this case, it has to be 3. 25 will not go into 12, but 25 will go into 120. So we're going to begin our answer over. I'm going to use a different color here. We're going to begin our answer over the first 0, okay? So how many times about will 25 go into 120? Now think back to when I taught you about 2-digit divisors. What you can do to get a ballpark number to start so that you don't have to just keep trying different numbers and trying different numbers is I would cover up and I would look at the tens digit and then I would look at these 2 digits and I'd say, well, about how many times will 2 go into 12? And it would be about 6. But this is not 20, this is 25. So if I try to put a 2 here, it's probably going to be too big. So I'm going to try instead of a 6, I'm going to try a 5 and see how that works. So I'm going to put a 5. I'm going to say that 120 divided by 25 is going to go 5 times. So now I do my multiplication step. 5 times 25. 5 times 5 is 25. Regroup the 2. 5 times 2 is 10 plus 2 is 12. Oh, look, that's still too much. So 5 was too much. So I'm going to erase this and I'm going to try a lower number. So let's try 4 because it wasn't off by a lot. It was just off by a little bit. I just had 5 too many. So I'm going to go and change it down 1. So, and I have to erase what I carried there. Okay, so 4 times 25 is 100. I know that because if I think of quarters, I know that 4 quarters equals $1, right? So I can just do that in my head. Subtract. 0 minus 0 is 0. 2 minus 0 is 2. 1 minus 1 is 0. I don't put that 0 there. Compare. 20 is smaller than 25 like it's supposed to be. It can, remember, this number when you subtract has to be smaller. It cannot equal your divisor and it cannot be larger than your divisor. So 20 is smaller than 25, so I'm good. So I bring down. Okay, I bring down my 0. So now I'm going to think again. Quarters, dollars, $2 and quarters. How many times? We know that 4 times 25 was $1. How do you suppose we're going to get $2? Yeah, double that. Since this is double this, then I'm thinking that if I put double this number over here, it's probably going to work. So let's see. We put in an 8 because 8 is double 4. Now I'm going to multiply. 8 times 25. 8 times 5 is 40. Put down my 0. Regroup my 4. 8 times 2 is 16 plus 4 is 20. Subtract. 200 minus 200 is 0. 0 compares is smaller than 25 and there's nothing to bring down. Now remember, if you got a remainder here with money, you did something wrong because we do not have another coin that's smaller than a penny. So you will never get a remainder in money, okay? Also, what you do is we never just leave this blank here. When we're talking about money, we go back and put the 0 in our answer. So now we know that the box of the box of 25 cards that cost us $12, it winds up costing us $48 cents per card for each card. Okay, 48 cents for each card. Now I can compare, because this was what the price of the cards was, and this was what the price of a whole box of cards was. Now we're comparing the same thing. Cards, price per card, price per card. So then which is the better deal? Is it better to buy each card by itself, or is it better to buy a box of 12, which will cost me less money? Hopefully you just told me that this one right here is the better buy. The box is the better buy. Box of 25 is the better deal, or the better buy. Now I always have to put this information in my all these extra words, because it's a word problem and you always have to give a label to the word problem. And just I circled my answer just because there's a ton of work here, and this is what your notebook page is going to look like. It's going to have all this work also, so you need to circle your final answer so that I can find it and check it more easily. Alrighty, let's do one more problem to see how we would divide by money to find which is the better buy. Let's say you were asked to divide $18 by 8. So let's say you were given this problem. You weren't given a word problem, you were just given a problem of $18. Let's write it the way they're going to give it to you in the book. They're probably going to give you something like this. $18 divided by 8 equals. So you have to, that's hot dog style. You have to rewrite it hamburger style, leaving yourself some room. So my dividend goes underneath. My divisor goes outside. And I already know that I have to add my 2 zeros to my dividend. And then I'm going to go and put my decimal point and my dollar sign in my quotient above where they are in my dividend. Now I can do the standard. Does McDonald's sell chicken burgers? Okay. All right. So where am I going to begin my answer? Will 8 go into 1? No. Will 8 go into 18? Yeah. So I'm going to begin my answer over the 8. Okay. So I put a little dot over the 8, but under the divided by line. All right. Now I'm going to say to myself, about how many times will 8 go into 18? Well, I know 1 times 8 is 8. And 2 times 8 is 16. That's kind of close. 3 times 8 is 24. Oh, that's too much. So it must be the 2 that we're going to use. So let's put our 2 in our answer over the 8. Multiply. 2 times 8 is 16. Making sure I line up my numbers correctly. Subtract. 18 minus 16 is 2. Compare. 2 is smaller than 8, so I'm good. So I can bring down my 0. 8 goes into 20 about how many times? Well, we already did up here 2 was 16, and that was pretty close. And then when we do 3 was too much. So I'm going to go with 2 again. I'm going to put 2 over my first 0 there that I added. Multiply. 2 times 2 is 16. 20 minus 16 is 4, and 4 is smaller than 8, so I'm still good. Now I bring down my last 0, and I say, how many times will 8 go into 40? Well, I know that it goes in 5 times, so I put a 5 in my answer, because I know my times tables really well. Multiply. 5 times 8 equals 40. 40 minus 40 is 0. 0 is smaller than 8. There's nothing to bring down. So I have $2.25 is my answer. Okay, let's see if there's any more that we should really go through. Probably not. I think that's a good enough example, so you're going to try some practice problems on your own.